Welcome to Vedavyasa Academy. In this session, we discuss the engineering mathematics. Engineering mathematics, that is second year, first semester paper, Mathematical and Statistical Foundation, MSF. So in this first chapter, that is greatest common divisors and prime factorization. So in this, what are the topics are there? Greatest common divisor, GCD, Euclidean algorithm, fundamental theorem of arithmetic, factorization of integers and Fermat numbers, congruences, introduction of congruences, linear congruences, Chinese remainder theorem, system of linear congruence. These are the topics covered in first unit. So we have to discuss about that in this session. Okay, all of you. That's all. Here we have the one definition from MSF, that is, if a comma b are two integers, if a comma b are two integers and a not equal to 0, there exists an integer q belongs to z such that a b is equal to aq. So this can be written as b is equal to aq, where q belongs to z. Z means integer set. Then we say that a divides b. We say that a divides b. A divides b. Q is equal to what? B by a means a divides b. So a is a factor of b. So a is a factor of b, or a is divisor of b. A is divisor of b, or b is multiple of a. B is multiple of a. The statement a divides b, here a divides b, the statement a divides b is denoted by a divides b like this. A divides b. If a not divides b, we write a not divide b like this. A not divides b. Okay, all of you. So suppose 3 is there. 3 divides 21. This can be written as 3 divides 21. Suppose 4 divides 20, can be written as 4 divides 20. 6 not divides 20. So 6 not divides 20. Like this we can written. Okay, all of you. If let a comma b are two integers, a not equal to 0, if there exists an integer q belongs to z, means q is the element number which is in a integer set, such that b is equal to aq, then we say that a divides b, or a is a factor of b, or a is a divisor of b, or b is multiple of a. The statement a divides b denoted by this one, a divides b. If a not divisor of b, we write as a not divides b. 3 divides 21 means 3 divides 21. 4 divides 20 means 4 divides 20. 6 not divides 20. It is not divisor of 20. So we write as 6 not divisor of 20. Like this we write. Here some of the note points are there. So some of the note points are there. If note 1, if a divides b, then minus a also divides b. If a divides b, minus a also divides b. That is b is equal to aq implies is equal to minus a into minus q. Minus into minus plus. So b is equal to aq equal to minus a into minus q. For non-zero integer a, we have a is equal to a into 1 minus a into minus 1. So my a comma minus a comma plus 1 comma minus 1 are divisors of a. So each of same element is divisors itself only. So a divisor of a. So we say a minus a plus 1 minus 1 are divisors of itself only, that is a. Okay, all of you. Then some of the properties of divisors. Here we have some more properties of divisors. What are the properties? You see, all of you. If a divides b, then b is equal to 0 or mod a less than or equal to mod b. So here you see, all of you, this is 3 divides 6. So here in this one, 6 divided by 3. If this is b, this is a, the b is equal to 0, then it is true. So here this 3 is less than 6. Suppose a is there, no. So a is less than or equal to b. So this is the property number 1. If a less than b, then b is equal to 0 or mod a less than or equal to mod b. Property 1. Property 2. If a divides b implies a divides minus b. A divides b implies a divides minus b. So 3 divides 6. 3 also divides minus 6. Okay, all of you. It is true. If a divides b, b divides c, then a divides c. A divides b, b divides c. Suppose 3 divides 6 and also 3 divides 12. 3 divides 6, 3 divides 12, then 3 automatically divides 12 also. So this is or 3 divides 6 and 6 divides 12, then automatically 3 divides 12. A divides b, b divides c, then a divides 6. Okay. If a divides b, b divides a, then a is equal to plus or minus b. A divides b, b divides a. That is here x by a and a by x. Means here you see, all of you, here what is a square is equal to x. X square. In this case we say this as in this case we say this is a by b is equal to b by a. A square is equal to b square. A is equal to plus or minus b. Okay, all of you. Then a is equal to what? Plus or minus b. AC by BC, then A by B. So AC by BC means BC by AC, CC cancel, B by A means A by B. A divides B. A divides B. If A by B, then for any integers x, A by bx. If a by b, then for any integer x, a by bx. If a by b and a by c, then if a by b and a by c, then for any integers x and y, a by bx plus cy. A by bx plus cy. This is the condition. If a by b, a divides b and a divides c, then for any integers x and y, a divides bx plus cy. These are the 7 properties of divisors. Okay. So here we are going to discuss about the numbers. In these numbers, you see all of you here natural numbers. Natural numbers. What are the natural numbers? What are the integers? What are the natural numbers? What are the integers? Here we have to use the numbers counting purpose. 1, 2, 3, 4, 5, 6, 7, 8, 9 are the counting numbers. After that 0 is there. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. These are the natural numbers, and these natural numbers we have to use the counting purpose. So here natural numbers are, this is starting from 1, 1, 2, 3, 4 and so on infinitive. It is represented by n. And what are the integers? Integers is represented by z, that is 0, plus or minus 1, plus or minus 2, plus or minus 3 and so on. These are the integers. Natural numbers, integers. Here in the chapter we deal with natural numbers and integers. Okay, all of you. So these integers and natural numbers. Here we introduce the prime numbers. Prime numbers. What are the prime numbers? Here you see this 2 is the prime number, 3 is the prime number, 5 is the prime number and 7 is the prime number, like that. So prime number means the number having the factors itself, number having the factors only two. One is the factor and itself is the factor. Then that type of numbers are called prime numbers. The number has factors or divides with one and itself. One and itself is a prime number. Is a prime number. Is a prime number. What are that type of numbers? You see, 2 is the one prime number, 3 is the one prime number, 5 is the one prime number, 7 and 11, 13, 19, 23 and 29 and 31, 37, like these are the prime numbers. And one more, composite numbers. Composite numbers. What are the composite numbers? Composite numbers are one and itself, not only one and itself as a factors, other also factors are there. Then we say that type of numbers are composite numbers. Or more than two factors are there, that type of numbers are, that is composite number. So here you see 4 is the composite number, set of 4, and this is set and so on. And 6 is the composite number, 6, 7, 8 is the composite number, 10 is the composite number, like these are composite number. Here what about 1? 1 is neither prime number nor composite number. Okay, 1 is neither prime number nor composite number. So prime numbers are the number has factors or divides with one and itself is a prime factor. prime number. So example 2, 3, 5, 7, 11, 13, 19, 23, 29, 31, 37 and so on. So composite number, the number have one and more than two factors, means one and itself and others also. Then that type of numbers are called composite number. Here one is there, one is neither prime number nor composite number. Okay, all of you, that's all. Here one more, you see all of you, we have the 6 is there. So 12 is there. 12. What are the factors of 12? 1 is the factors. Factors. 1 is the factor. 2 is the factor. 3 is the factor. 6 is the factor. 12 is the factor. Okay, all of you. And you take 18. That is 18 factors. 1 and 2 and 3, 6, 9, 18. These are the factors. Okay, all of you. Here you see all of you, common factors are. Here what are the common factors? These are the common factors. 1, 2, 3, 6. 1, 2, 3, 6 are the common factors. In these common factors, 6 is the greatest common factor. Means 6 divides 12 and 6 divides 18. So we say this greatest common factor. Greatest common factor. Common factor 6 is the greatest common divisor of 12, 18 is equal to 6. Okay, all of you. So here 6 is the greatest common factor. When you take 12 and 18, then 6 is the, we say as 6 divides 12 and 6 divides 18. Then we say GCD of 12, 18 is 6. And this is the one process, one method to find the greatest common divisor. And suppose larger number is there, we follow the other method. So second method is what? Second method to find greatest common divisor, that is GCD, is very most important, finding the GCD. So we have to find GCD of these two numbers, that is 12 of 18, 12 1 12, the remainder is 6. So you can write this 12 as here, 6 2 12 and 0. So we say this is the greatest common divisor. Then we say GCD of 12, 18 is equal to 6. Okay, all of you, that I hope you understand very well this greatest common divisor, and some of the examples we can do explaining this GCD of greatest common divisor of numbers. So just greatest common divisor of A comma B denoted as GCD of A comma B. GCD of A comma B. So GCD of A comma B is equal to GCD of B comma A. GCD of A comma B is equal to GCD of B comma A. Here we have the sum of the properties of GCD. So What are the properties? You observe, all of you. GCD of A comma B is equal to GCD of B comma A. Always GCD of A comma B is equal to GCD of B comma A. Means whichever smaller is, you can take first and greater as second. That is the GCD. And if GCD of A comma B is equal to D, then D is unique. Okay, and unique. If GCD of A comma B is equal to D, then D greater than or equal to 1. GCD of A comma A is equal to modulus of A. GCD of A comma B is equal to GCD of minus A comma B is equal to GCD of A comma minus B is equal to GCD of minus A comma minus B. That is GCD of modulus of A comma modulus of B. And GCD of A comma 0 is equal to modulus of A. So GCD A comma modulus of C comma B, C. Then GCD of A comma B divides C. We write as GCD of A comma B divides C. These are the 7 properties of GCD. Okay, all of you. That's all. These are the 7 properties of GCD. Here, question is given. Find the GCD of 4, 414, 662. This is the first question. Second question, third question. How to find GCD of this one? GCD of this one is, here first we have to take the smallest value as A and greatest value as B. So here this is the smallest value A, this is the greatest value B. So 414 of 662 of 414 the 1, that is 414. And this is 12, 12 minus 4, 8, and 5, 5 minus 1, 4, and 6 minus 2, 48. Again, you can take into this side and 414. 414. This is 1 ja 248. Okay, all of you. This is the 14. 14 minus 8, 6. 10, 10 minus 4, 6. And here 3 is there, 3 minus 2, 166. Again you can write this 248. Okay, all of you. So 166, 1 ja 166. 8 minus 6 is 2. 14 minus 6 as 8. 82. Again 166. 82 2 ja 2 2 ja 4, 2 8 ja 16. This is, what is 6 minus, this is 2, 82 ja. So here this is 82, again here 82, 82, and here what is, sorry, this is 2. 2 is the remainder and 82 here you write. 2 how many times? 2 41 ja 82 0. When we reach the 0, so this remainder is the GCD of these two numbers. Okay, all of you. Then here you write as GCD of, that is 414. 414 comma and 662. 662 is equal to 2. This is the GCD of 414 comma 662. Okay, all of you. So this is the GCD of these two numbers. We do like this up to 0 remainder. Up to we get 0 remainder. Up to there you can do this one. And when this 0 remainder is occur, that divisor is the that divisor is the GCD of two numbers. Okay, all of you, GCD of two numbers. Therefore, 414 comma 662 GCD is 2. We calculate as 2. Now we calculate the GCD. This GCD of 414 comma 662 is equal to 2. Now we calculate the GCD of these two. Okay, all of you. Now we have to calculate GCD of these two. Here smallest number is A and greatest number is B. We take like this. So here GCD we have to find. GCD of these two numbers. A is equal to 143 and B is equal to 227. And 143 of 227 of this is 143 1 ja 143 7 minus 3 is 4 and here 12 is there 12 minus 4 is 8 84 here 143 you write here 84 2 ja 160 is there so this is 84 and 13 minus this is 9 and here 13 is there, the 13 is there, this is 59 and 84 1 ja 59, this is 14. 14 minus 9 5 and here 7 is there, 7 minus 5 25 59. So how many times? 25 2 ja 50 and 9 is the remainder and 9 is the remainder 25. 9 2 ja 18 and this is 7. This is 9. 7 1 ja 7 and this is 2. 7 is there. So 2 3 ja 6 and 1 2 is there. 1 2 ja 2 and 0. So this 1 is the GCD of these two number. Therefore, we can write GCD of 143 comma 227 is equal to 1. GCD of 143 comma 227 is equal to 1. Okay, all of you. Similarly, you have to calculate the this is 143 comma 227 GCD is equal to 1 and you have to calculate this this is that is 493 GCD of 493 2210. So here smallest number is 493 and you taken as A and this is B. Then you have to calculate GCD of these two numbers. These are the I calculated and you can calculate this one. This as the assignment for you. Okay, all of you. That's all.